And this is review session 10. I'm going to continue concentrating on figures in chapter 22. And so we are now on page 843 to figure 2221. And a quick glance will confirm that this is a figure showing meiosis. And then a closer look will show that more specifically, this is a figure showing a process called oogenesis, the production of egg cells, the type of meiosis that produces egg cells. And so, running through from left to right, we start with a diploid cell, as we always do with meiosis. And now notice specifically in females, this diploid cell that we're beginning with is called a primary oocyte. Following the arrow then, and this primary oocyte undergoes meiosis 1, undergoes the first meiotic division, producing, as meiosis always will at this point, two cells which are both haploid and in which both have chromosomes, each consisting of two joined sister chromatids. And notice now in terms of terminology, after meiosis 1 or during meiosis 1, we're going from a primary oocyte to a secondary oocyte. Recall also that during meiosis 1 in oogenesis, in addition to a much larger secondary oocyte, so up at the top, we're also producing a structure called a first polar body. We're getting rid of 23 chromosomes that we don't really want around, we don't really need. And then that first polar body may or may not undergo meiosis 2. Doesn't matter if it does, because in any case, these polar bodies that are produced will all degenerate, will all break apart. We're turning our attention now back to the important cell here, the most important cell, the secondary oocyte. And notice then from the figure, the secondary oocyte is the stage that will become fertilized if in fact fertilization does occur. And so notice now in the figure we have our sperm cell with 23 chromosomes fertilizing the egg cell with 23 chromosomes. We are back now to our diploid number of 46 chromosomes. And from here, meiosis 2 produces from that fertilized secondary oocyte, meiosis 2 produces two cells, one of which has 46 chromosomes, 23 from the sperm cell, 23 from the egg cell, and this cell is now called a zygote. This is the cell that will, by the process of mitosis, grow very rapidly through repeated, very fast mitotic divisions into a fetus and then an embryo. And the other cell that's being produced at this time is the second polar body, which also degenerates. Also notice on page 843 and figure 22.1, the B portion of the figure, the photograph that we're looking at, is a nice look at a secondary oocyte with the first polar body that was produced at the same time that secondary oocyte was produced. Taking a look now on page 844, the figure at the top of the page, and what we have here essentially is the development of a follicle. So let's start with the labels, and the number 1 label then in that series of boxes with arrows going from left to right as we move along the process. And so we start with a primordial follicle, which develops into a primary follicle, into a preantral follicle, into a mature antral follicle. So again, these are terms, these are structures you are familiar with. from doing your lab work before you got to this point. That mature antral follicle, then remember, is the stage which releases a portion of the follicle during ovulation. And so at ovulation, then, a secondary oocyte is being released with its surrounding corona radiata. And then remember, remaining behind is the other part of the follicle. Remaining behind in the uterus, remaining behind rather in the ovary is the other part of that follicle, the part that wasn't released during ovulation. And this remaining clump of cells then is the corpus luteum, which then over time degenerates, decays into this scar-like corpus albicans. From here, as far as the figures go, we flipped over to page 850, I believe, and figure 2230. And so looking now at the control of female secondary sex characteristics, and again, just running through the figure quickly, the hypothalamus at the top, producing a releasing hormone, which in turn causes the pituitary gland to release FSH and LH. And so the same process up to here in females as we saw earlier in males. The FSH and the LH then acting on the ovaries, and the FSH stimulating maturation of primordial follicles. And so going from those primordial follicles through the various stages that we just looked at, and FSH also stimulating meiosis. And notice what we're seeing here is meiosis 2, primary oocytes turning into secondary oocytes. Also notice, in terms of what LH is doing, luteinizing hormone, and so it's part of this process, it's part of the cause of this process called ovulation. And then again, to the figure, the remaining follicle becomes the hormone secreting corpus luteum. Following the arrow up now from the ovary, and so we have estrogens being produced, producing a variety of effects that we talked about, including some of the, including the secondary sex characteristics, promotion of the secondary sex characteristics of females at puberty. And then again, the remainder of the figure, the upper right-hand portion, really just reminding us that this process of negative feedback will prevent over secretion of hormones and over production of these various structures. And then finally, we talked about the menstrual cycle. So figure on page 22, figure 2231 rather, on page 852. We did this, we went over this in conjunction with table 22.4. And again, just running through that list of events in figure 22.4, that list of major events in a menstrual cycle. And so we have the anterior pituitary secreting FSH and LH. Glance over and find that. You should pretty much be able to get there very quickly by now. The FSH stimulating maturation of a dominant follicle, so the lower part of the A part of the figure. The follicle producing and secreting estrogens, down below then. The upper part of the B portion of the diagram. Estrogens causing the endometrium to thicken, so now down to the lower part of the B portion of the diagram, looking at the thickness of the endometrium. Anterior pituitary releases a surge of luteinizing hormone interacting with FSH and progesterone. And so again, recall from the figure, you're seeing now a spike in levels of LH and FSH and progesterone, all at this point just before ovulation, leading to ovulation. Following ovulation, again, we have a corpus luteum left behind in the ovary, and that corpus luteum secretes estrogens and progesterone. Estrogens continue to stimulate the uterine wall development, and progesterone stimulating the endometrium to become more glandular and vascular. So again, we're down at the bottom part of the figure now. Estrogens and progesterone inhibiting the secretion of FSH and LH. Again, not really shown very well on the figure. If fertilization doesn't occur, then the corpus luteum degenerates into a corpus albicans. It becomes non-functional. It's no longer secreting its hormones. As the corpus luteum then is secreting less and less hormone, fewer and fewer hormone molecules, blood vessels in the endometrium constrict. The uterine lining disintegrates and sloughs off, producing a menstrual flow. And so now we're way off to the right of the lowest of those four parts of the figure. Anterior pituitary again secretes FSH and LH, and the cycle starts over. And again, notice then on the timeline down below, way off to the right after that day 28, we're into the first 3 days of that 28-day cycle. And so the very right portion, where it goes 28 and then 1 and 2 are implied and then 3, that overlaps, going way over to the left with day 28 and then 1 and 2 implied and then number 3 being labeled. And that concludes review session 10.